You know, if you're quiet enough, you can actually hear the beating of your heart like up in your ears. Sometimes you can even feel it like in your fingers, your arms. It's pretty cool. Your heart's actually a really, really amazing, amazing muscle. I want you to imagine this for a second. Imagine taking a tennis ball. Imagine squeezing a tennis ball every second of every hour of every day, 24 hours a day, 7 days a week, every year for the rest of your life. And if you stop, you die. That'd be horrible. I'm just saying, that would just be really, really horrible, right? Why? Because you squeezing that is like your heart squeezing the blood that pushes the blood through your body, okay? You squeezing that tennis ball, your forearms would cramp out pretty quick. Within a couple of minutes, you'd want to switch hands. You'd want to do something. Your heart can't do that. There's only one of it. So it's got to keep going. So it's an amazing, amazing muscle. And it's not even 60 beats a minute. That's like if you're like this insane athlete and you're resting. Most of us have a heart rate of closer to 80 to 90 beats a minute. So it's like almost one half again as fast as that. You're looking at two squeezes every looking at 3 squeezes every 2 seconds. All right, you're really pumping it to get that blood flowing. You would cramp out really fast. But it's important to recognize the strength of the muscle of the heart, because it's the thing that keeps you alive. You're not going to die until it stops, or it's not going to stop until you die. I suppose whichever one comes first. Never mind. Don't think about that too much. So your heart actually is an amazing muscle. It comes in 2 sides. You got 2 sides to your heart. You've got the right side, you've got the left side. The right side of the body, the right side of the heart, is the part of the heart that's going to receive blood from the body. The body's going to be draining the blood back to the heart. It's going to put it into the right atrium. That's going to get pumped down into the right ventricle. And then from the ventricle, it's going to get pumped out through the pulmonary trunk and back into the lungs. Why is it going to the lungs? Well, it just spent its routine in the body. It's dumped all of its oxygen. And it's picked up all this carbon dioxide, and it needs to get rid of the carbon dioxide and pick up more oxygen. So it's got to go to the lungs next. So from the body, the blood flows in through the superior and inferior vena cavas. Those are the 2 largest veins in your body. They go into the right atrium, down into the right ventricle. The ventricle, the lower part of the heart, that then squeezes the blood and pushes it through the pulmonary trunk out into the lungs for gas exchange. All right, in looking at gas exchange, you'll have to watch the video on respiration, on the respiratory system. Then you can see what's happening there in the lungs. All right, once we've gotten rid of the carbon dioxide and we've picked up the oxygen, the blood then returns through the pulmonary veins into the left atrium and gets pushed down into the left ventricle. That's the largest chamber in the heart. It's the largest because it has to pump the blood through the rest of the body. So when the left ventricle contracts, it's going to push the blood out through the aorta, largest blood vessel in your body. The aorta is going to turn and run down just inside of your backbone, down, splitting at the pelvis, going down into your femur. It's got little vessels that go to the kidneys and other vessels that go to the digestive system, and it's pretty much hitting blood everywhere it goes. Right? That's what's going to feed the blood through the lower part. Coming off the top of the aorta, you've got these 3 little blood vessels. You've got the brachiocephalic trunk, you've got the left common carotid, and you've got the left subclavian. The brachiocephalic trunk actually is going to split, and it's going to take the blood up the right side, the right common carotid, into your brain on this side. And subclavian means under the clavicle. It's going to split into the right subclavian, taking blood down into your right arm. Okay, so that's the brachiocephalic trunk. The left subclavian goes straight from the aorta right up to the left side of your brain or left side of your head, and the left subclavian goes underneath the left clavicle and down into the left arm. So that feeds the upper part of your body, where the aorta then turns and splits off into some of the costal arteries and the renal arteries and all the different things, taking blood to the rest of the body going back down. Okay, so that's the way the heart is going to work. It's an amazingly powerful system. It's got to constantly keep going. You've got to take care of your heart, because if you don't take care of your heart can't take care of you. And we would miss you. So take care of your heart. It's good stuff. eat your Cheerios, right? It's a heart healthy cereal or so. Yeah, and Cheerio now owes me like a little kickback. I'm advertising for them. I don't know. They're probably going to sue me. All right, so here we go. So that's the idea. The blood's going to flow around and flow through. All right, now these different blood vessels, there's three major types of blood vessels you have. You have the arteries, you have the veins, and you have the capillaries. The arteries carry blood away from the heart. Please, please, please don't make the mistake of saying the arteries carry oxygenated blood while the veins carry deoxygenated blood. That is only true for the left side of the heart. The right side, the artery, is carrying the deoxygenated blood to the lungs, okay? So please remember it this way. The arteries carry the blood away from the heart. They're thick, they're muscular to withstand the pressure of that heart that's pumping on it. That's what produces your blood pressure. It's the pumping of your heart. It squeezes then, causes your arteries to expand to absorb that energy from the pumping of the heart, that pressure, okay? That carries the blood away from your heart. The veins then drain the blood back from your body back into the heart from the body. There's no pulse in the veins. When you look at the veins that you see in your arms or other parts of your body, there's no pulsing going on here. Those are veins, they're superficial, they're draining the blood back. Okay, we got to get it back to the heart. Okay, what connects the two throughout pretty much all of the tissues of your body are the capillaries. Capillaries are small microscopic vessels, thin-walled, oftentimes only large enough to allow one red blood cell at a time going through them. They're very tiny. This is where everything happens for the circulatory system. This is where oxygen and nutrients are dumped into the cells. This is where waste products are picked up. Carbon dioxide is picked up. This is where hormones grabbed from different parts of your body are transmitted and carried over to other parts of your body. All this stuff is going on. Your circulatory system is like the great transportation system of your body. Okay, and all this is happening inside of it. So as these things are getting delivered, all of that's happening through the capillaries. That's why they have to be thin-walled. There's no blood pressure in your capillaries at all. Most of your capillaries are not even open right now. Your capillaries open up on demand. If you get embarrassed, the capillaries in your cheeks open up, which is why you feel flushed, which is why you feel your cheeks turn red, okay? If you get a sunburn, you've damaged the cells in your skin. You've damaged them. UV light has destroyed parts of your tissue. So the blood is flowing to that area of sunburn to help to heal it, bringing white blood cells, try to remove any damaged cells, tissues, bringing oxygen to them to help them to heal faster. That's why your skin turns red when you're sunburned, because of all the damage that you've done to it, okay? So this is the way that that works. If all of your capillaries were to open at the same time, your blood pressure would plummet almost to nothing and you would probably die. So that's not a good thing to happen. So your blood vessels, the capillaries, really only open up on demand when you're calling for the need. This is why, athletes, it's important that you warm up and you do a warm-up run before you go into your soccer game or basketball game or track meet or swim meet or volleyball, whatever it is you're doing. This is why it's important to warm up, because what you're doing is you are now flooding. By doing a warm-up, you're producing a stress on your muscles, a demand on your muscles, and that causes those capillary beds to open up and begin to deliver oxygen, get rid of carbon dioxide and waste materials from the production of ATP. All that's going on in your muscles. So it's important to do that before your athletic competition, because if you wait, you're going to do that for the first part of your athletic competition, and you're not going to be as efficient in what you're trying to do. So you want to make sure that you do a good warm-up, and it's all about opening up those capillary beds in your muscles, in your legs, in other areas, so that you can be at your peak performance level when you go to do that, when you go to compete. So the blood's going to flow from the heart through the arteries. From the arteries, it's going to get pumped into the capillaries. There's where all the exchange and all the good stuff's going on with your cells of your body. Only some of those are open at a time, not all of them. And then once that's done, the blood drains back through your veins and back into your heart to repeat that cycle and do it again. Those are the basic parts of the circulatory system. Now, within the circulatory system, in the blood itself, blood is actually composed of several different components. You've got the red blood cells. These are the cells that are necessary for carrying oxygen. Okay? They're produced in the flat bones of the body. They're used for about a month. By then, they're all beaten and dinged up and scarred and everything else, and they got to be destroyed. So they go to the spleen. The spleen's pretty much between the spleen and the liver. They're going to destroy all the bad red blood cells. They're going to get rid of them, and your body's going to make new. About every 30 days, you have a brand new set of blood flowing through your body as far as the red blood cells. Okay? Your white blood cells are a part of your immune system. They're traveling around looking for indications of damage, either bruising or other areas, or an injury or an infection. Your white blood cells are cruising around looking for that. When it finds it, they begin to mobilize like an army to attack whatever is trying to invade, whether it's coronavirus or bacteria or anything. It doesn't matter. They're going to be out there trying to get that done. It could be simply, oh no, I hurt myself. And now those damaged cells, the white blood cells, are going to go and help to clean up all that mess inside of me, make sure that I stay nice and healed. Both of those types of cells are floating around in what's called the plasma. The plasma is just this thick kind of fluid. If you've ever had a little bit of a burn, you know, that yellowish fluid that occurs. If you've ever had a blister, that's kind of what your plasma is. Okay, it's that fluid that is flowing around, carrying all this stuff. The last component of your blood are called the platelets. The platelets are the things that are responsible for blood clotting. Blood clotting is critical in your body, but it's only critical when you get a cut. It is very, very important, muy importante, that when you get a cut, that blood clots at the site of the cut and nowhere else. You don't want your blood clotting everywhere. You would die. You don't want to get a cut and your blood not clotting at all. You would die. So you only want it clotting where it cuts. And that's very important. And that's a whole process called the blood clotting cascade. It's multiple steps, over 12 different steps, things that have to happen in a specific order in order for blood to clot, and only clot where you need it to clot and nowhere else. It's very, very important to have. And that, my friends, is the circulatory system.